It rained down destruction on armies from tremendous ranges. Originally, palletized weapon systems were employed by airdrop using a specialized box to aid in a drop-off. This system allows for the box to be rolled on and off as desired in rapid succession. It then rained down many different sorts of artillery down on its target. Rapid Dragon, I would state, is an upgraded version of the previous program, as it goes into detail of efficiency and assessment of utility for larger volumes of longer-ranged missiles. Rapid Dragon system, or the Rapid Dragon bomb, is fairly new, but the use of pallets and airdrops have been around since World War II. Airdrops are simply the evacuation of weapons, equipment, or aid from either a military plane or civilian plane without landing. Early drops during wartime consisted of padded bundles that were either pushed out or dropped from the plane. These drops helped troops who had no accessibility to supplies because of obstacles that stopped them, such as terrain, weather, and location of opposing forces. Eventually, parachutes were used to gently lower down supplies. Then an enhancement was developed to effectively eject the cargo. Cargo aircraft were then enhanced to use rear ramps where they can just roll out the cargo during flight, rather than manually pushing massive weapons, aid, and equipment. It was a slow evolution from stiff drops to gentle releases by the Air Force. There was even the creation for low-level extraction, which allowed the delivery of weaponized vehicles, like tanks or larger supplies. The progression of development and creation has led to what we're talking about today, a sophisticated way to not just drop cargo, but using similar tactics to weaponize planes. The weaponizing of planes is not necessarily new. In history, humanity has witnessed airdrops of bombs since World War II, like Fat Man or Daisy Cutter. But these bombs were deployed from planes either specifically made for bombing, like the Boxcar, a bomber plane that released Fat Man or the atomic bomb over Nagasaki, or planes not meant to handle a lot of payload, like heavy-duty transport planes. This is where Red Dragon comes in, as it was made to discover more possibilities for airdrops and possibly weaponizing harmless planes effectively. The development for Rapid Drop began in 2019 with about 30 stakeholders looking into the development and the system's potential to change the game for the Air Force. Those stakeholders included the Air Force Major Commands, Department of Defense, and multiple organizations within the Test and Evaluation Department. These stakeholders helped develop Rapid Dragon by putting it through simulations, analyzing data created from test flights, and modeling of the system. Recent tests were run on the system to gather enough data on its use. The final test that Rapid Dragon had gone through was just completed in December 2021. This was done near the Gulf of Mexico, closest to Florida. The aircraft involved with the test was the MC-130J Commando 2 aircraft. Rapid Dragon did exactly what was theorized and tested to do. Data was inputted and changed mid-flight into the module, noting this was the first time this has ever happened, and then proceeded to be airdropped with parachute and pallets intact. The tricky part was if the cruise missiles would properly deploy from the pallets and hit the correct target. Fortunately, the target was hit as planned. The missile stabilized, released, and pulled up appropriately to hit the intended target, which was imputed by the pilots. The next step in development for the Air Force is to test the system again, but this time using a different aircraft, preferably the C-17 Globemaster III aircraft. This test has not taken place as of yet, but is set for sometime in around 2022, and the goal as of now is to certify multiple aircrafts with the ability to use cruise missiles. This concept was originally given to the Air Force to have the upper hand in protecting and weaponizing typical transport and cargo planes. It also gives them a chance to confuse enemies who may target these planes and also discourage any future attack. Another big reason for their development was to be prepared for near-peer conflict with China and Russia. The Air Force wants the ability to hightail out of a terrible situation like incoming missiles. It seems that since the change in program to Rapid Dragon, these palletized missiles may find even more use once successfully developed. Since the Rapid Dragon weapon systems are so new and still in the testing phase, all we can do is compare similar weapons out there for the specifications. It has been stated that it is very similar to AGM-158B or JASM-ER when it comes to aerodynamic similarity. The AGM-158B, also known as the Joint Air-to-Surface Standoff Missile, is a type of standoff air-launched cruise missile. The weapon has an armor-piercing warhead that weighs 450 kilograms, or for our Americans, that's about 1,000 pounds. Now for the specifications of the missile. The speed is considered subsonic, right below the speed of sound, and the range of flight can travel 575 miles in distance. The dimensions of this missile would be around 4.27 meters in length, 2.4 meters in wingspan, and 975 kilograms in total mass. Translation would be 14 feet in length, 7.9 feet in wingspan, and 2,150 pounds in mass. Now let's discuss the pallet, since the missiles are being held and stored in it. Depending on the aircraft, the pallet deployment box can hold 6 or 9 cruise missiles. The box itself is not sealed or closed up in any way, but is a metal frame that breaks in half to release the missiles when deployed. And what's interesting is that the box can be either stacked or set up in rows on the pallet, as long as the parachutes and module is in place. For the planes that were used, or you could say they are compatible with the Rapid Dragon system, are the MC-130J Commando II aircraft and C-17 Globemaster III aircraft. We do not know the dimension of the system itself, so we have to base everything on the 2 aircrafts the Air Force has tested on or will test on in the future. The first aircraft is the MC-130J Commando II, which is the same aircraft that had the successful test done with the system. The purpose of this aircraft is for refueling other aircrafts, resupplying airdrops, exfiltration, and infiltration. The max takeoff weight is 164,000 pounds. The speed is 362 ktas, knots true aerospeed, at 22,000 feet. The range when not refueled is about 3,000 miles. The ceiling of this aircraft is about 28,000 feet with a 42,000-pound payload. For those who don't know about aeronautics, a ceiling is the max density altitude an aircraft can reach under a set of conditions determined by its flight envelope. The other aircraft that will be using the Rapid Dragon system is the C-17 Globemaster III aircraft. The C-17 is one of the most flexible cargo aircrafts in the Air Force. The purpose of this aircraft is for airdrops, airlifts, transports, and even aeromedical evacuations. The max takeoff weight for those aircraft is 585,000 pounds, 265,352 kilograms. The cruise speed is 450 knots with its initial cruise altitude at 28,000 feet, 8,534 meters. The payload is around 164,900 pounds, 74,797 kilograms, but the maximum is 170,900 pounds, 77,519 kilograms. And lastly, an unfueled C-17 can go about 2,400 nautical miles in range. If the retest were successful on the C-17, then the capabilities brought upon by Rapid Dragon can continually advance the repertoire of the Air Force. Now for a recap summarization of what we know about Rapid Dragon. We know that it is fairly new, as it began in development during 2019. Data about this system is still unreleased, but we do know about the testing and development advancement the Air Force has made with this new technology regarding the pallet control module. The fact that information can be relayed mid-flight of an aircraft to the missiles is quite amazing. It may sound like a simple function, but it's important for the missile to succeed in rerouting on a moment's notice. The plan now for Rapid Dragon is to undergo another test on a different aircraft to look for whether the rerouting can be replicated on C-17 as well as other specifications. These specifications include a demonstration in high-altitude drop, deconfliction of operationally relevant payloads, and jettison. This retest would be considered Phase 4 in regards to the development of Rapid Dragon. And the crazy thing is, this program has been done in almost 2 years, which is fairly quick. We will have to wait and see if there are any developments in this Rapid Dragon system and the impact it will have in the current conflicts in the world with Russia and Ukraine, and even with China. In an effort to gain every possible advantage, the U.S. Air Force may have achieved a sophisticated method of modern artillery rapid fire. This system could be called a bomb due to its explosive nature, but it is actually known as the Rapid Dragon program, or as the Rapid Dragon Palletized weapon system. This system is much different from the standardized palletized munition systems used before. It is a system that involves long-range missiles stored in pallets on board of harmless cargo or transport planes, such as the C-130 and C-17 by the Air Force. These pallets are equipped with parachutes and a pallet control module. The pallet control module relays target information directly to the missiles and can be changed on a moment's notice by the pilots mid-flight through the plane. The missiles themselves, once dropped, will move by themselves to the designated target using the wind and